జీవన్ స్క్రీన్ షేరింగ్ ఎనేబుల్ చేయాలి.
Excuse me, sir.
Yeah.
ST also will be example one. The example.
Which one?
Density.
Yeah, density also we can take. Okay, right. Another very important example. I'll explain about this one later at the right moment. First, just note down. Expansion work.
Can you repeat it, sir?
Expansion work done in a reversible process. So usually work done is a path function, right?
Yes, sir.
But this is the same work done, but in the expansion process as well as in the reversible process. It is state function. Very important. I'll explain at the right moment. We will discuss in detail about each and every process in the future lectures. There I'll discuss about it. Okay. Expansion work done in a reversible process is a state function. Next, path function. Path function. The property in which the change in property depends upon
The property in which
the property in which the change in property depends on the path. How the final state is reached from the initial state. How the final state is reached from the initial state.
Sir, the last statement can you repeat?
How the final state is reached from the initial state. Okay. Right, guys. Now, suppose if I'm taking a cyclic process. If a cyclic process I'm taking. Suppose if Z is a state function. Suppose if Z is a state function. If Z is a state function, what about changing that state function in a cyclic process? Think carefully.
Can you repeat?
Path function, sir.
No, I'm considering if Z is a state function.
So
if
zero
Z is a state function, yes. Here the system is operating in a cyclic process.
Yes, sir, because there will be zero displacement, I can say in that terms.
Right. Okay. So here, what is happening? I am taking a system at this point A, and that system is operated in this cyclic process like this. Cyclic in the sense, ultimately, initial state is reached. So for a cyclic process, always initial state and the final states are equal, right?
Yes, sir.
Yes, sir.
For a cyclic process. Now, Z is a state function. State function depends upon only initial and final state, right?
Yes.
Yes, sir.
What is dz? Dz nothing but Z final minus Z
Yes.
initial.
initial.
Both are equal.
0.
Therefore, it will be
Yes, sir. 0.
0. Right. Right. If Z is a state function for a cyclic process,
Under cyclic process or continuation.
no, I'm dictating.
So,
Note down.
excuse me, sir.
They're like a non.
Sir, this function, path function has some symbols, sir. Like
No,
like
they
what we
don't.
have for
No.
pressure, volume, and all.
Well, if you take up pressure as a function, then it is state function. If you consider volume as a function, that is state function.
No,
If you
like they
consider
denote by
work as a
path.
function, then that is path function. There is no specific symbol for any state function or path function.
Okay, sir. Okay. Thank you, sir.
Okay. If Z is a state function for a cyclic process, if Z is a state function for a cyclic process, then delta Z equal to 0 or dz is equal to 0. Okay.
Yes, sir.
Okay. Suppose, see, so far we have discussed about 5 important thermodynamic processes: isothermal, adiabatic, isobaric, isochoric, and cyclic. So first 4 thermodynamic processes you can understand in terms of even graph. Suppose if you draw pressure versus volume. Suppose if you get this kind of curve. What does it mean? This curve indicates which process. Is it isothermal or adiabatic or isochoric or isobaric?
Isobaric.
Isobaric, sir.
Isobaric.
Yes, this curve indicates isobaric. Okay, therefore this is isobaric.
Isobaric.
Suppose if you get this kind of curve.
Isochoric, sir.
Isochoric.
There is no
Isochoric.
horizontal line.
Yes, this is isochoric.
Choric.
Suppose if you get this kind of curve
Abatic.
and there is another kind of
Adiabatic.
curve.
Adiabatic.
Now between these two, suppose curve 1 and curve 2, between these two, which is isobaric and which is isothermal and which is adiabatic.
So the
Both
second
One is isothermal, sir.
same.
The first one is abatic.
Top
One
one
is
is,
isothermal and
First one is isothermal, second one is adiabatic.
how can
Yes,
you
sir.
say that? How can you say that?
So because you have already given the graph of adiabatic, sir.
When did I give?
So you gave, sir, before or not?
No, I don't think so. No. See, with your knowledge, you cannot understand at this moment why isothermal. So the top one is isothermal and the bottom one is adiabatic. It is always that you guys understand after a few lectures. Of course, it is easy to identify isobaric and isochoric simply by looking at curves, right? Because throughout the process, pressure remains constant. Therefore, it is isobaric. Throughout the process, volume remains constant. Therefore, it is isochoric. Both are rectangular hyperbola, isothermal as well as adiabatic.
Adiabatic.
Now, what difference can you notice between isothermal and adiabatic when you look at the curves?
The slope of isothermal curve is less than slope of adiabatic.
Yes, very good. Yes,
dt is 0.
slope of adiabatic process is greater than slope
Slope
of
of isothermal, sir.
isothermal process. See, when you compare this one with this one, this is a slope, and this is, you can see this is the slope indirectly, and this is a slope for adiabatic process. So that you will understand from 2 important relations. So that also with proof we will discuss in coming lectures. But this graph is important. When the graph is given, it is important to identify which curve indicates which process. Okay, right on next one. Reversible and irreversible processes. Reversible and irreversible processes. reversible and irreversible processes. See guys, so reversible and irreversible, they are quite important. Reversible and irreversible. One second. Okay. See, reversible and irreversible, the major difference is reversible stands for reversible doesn't mean the process gets reversed. There is a slight difference between a reversible reaction and a reversible process. Suppose if you talk about reversible chemical reaction in the sense, suppose if reactant A is converted to product B. After certain time t, if B is unstable, that B will be reversed to form reactant A. So that is called a reversible chemical reaction. For example, if you take up calcium carbonate, the best example. Calcium carbonate, if you heat it, it will give calcium oxide and carbon dioxide. Suppose if you do not maintain proper temperature, after certain time, they will again recombine and that will give back calcium carbonate. So here the process is called a reversible chemical reaction. But it may not be reversible process. That means there is a difference between reversible chemical reaction and reversible process. Anyhow, you guys have some idea about reversible chemical reaction. Now let's discuss about reversible process. Reversible process in the sense, the process which occurs very, very, very slowly. Any process, it can be any process, but that should happen in dead slow manner. In the sense, suppose if a person has to move from this point to this point, let's say the distance between the 2 points, let it be some 1 kilometer, just 1 kilometer. The person started walking from this point. To reach the end point, if person takes some 100 years of time, you can imagine how dead slowly he walked throughout the process, correct?
Yes, sir.
Such a slowest process, very, very, very slow process. Practically, it seems to be ridiculous. It seems to be impossible, right?
Excuse me,
Yes, sir.
Such, first let me finish, guys. Don't
Okay,
interrupt
sir.
with your doubts meanwhile. First let me finish, after that you can start asking questions. Otherwise, if you start pinching for each and every silly point, the main point may get missed out. Okay? Just write down aside. If you guys have any doubts, just write down aside. Definitely I'll discuss all your doubts. But first, let me finish the point. Okay?
Okay, sir. Sorry, sir.
Yeah. So that such a slow process it is, or you can tell, let's say this is the closed container in which this is filled. The entire container is filled with a gas of some 1 liter of gas, hydrogen gas. And a piston is fitted with it. freely movable piston, frictionless piston. Suppose if the pressure inside the system because of this 1 liter hydrogen gas, let it be some 0.01 atmospheres, or better to take up 1.01 atmospheres, and the outside pressure is 1 atmosphere. Very clearly, there is a difference between the pressures. The pressure inside the system is slightly higher than the pressure outside the system, correct? Because of
Yes, sir.
that pressure difference, definitely the piston will be pushed in the upward direction, correct?
Yes,
Yes,
sir.
sir.
Suppose if I have taken the same cylinder, closed cylinder, instead of taking 1 liter, suppose if I'm taking some 0.00000 liters, very less volume. Because of that very little quantity of hydrogen gas, if the pressure inside the vessel is some 0.00001 atmospheres, and the outside pressure is 1 atmosphere, you can see there is a significant difference in their pressures, correct?
Yes,
Yes.
sir.
Yes, sir.
Now outside pressure is very high when compared to inside pressure, therefore that will be pushed. That will be pushed in the downward direction, but with great force. It happens a bit quickly, correct? Than
Yes,
the
Yes,
sir.
previous
sir.
case.
Yes, sir.
So both are realistic, in fact, both are feasible. I'm taking another example. Both are not reversible, correct? I'm taking another example. Take up another one. Again, into which some hydrogen gas is taken. Because of that hydrogen gas, if the pressure is 1.0000 some 001 atmospheres, and the outside pressure is 1 atmosphere, there is a piston, just like the previous case. Now between them, the pressure difference still there, but it is very
Very low.
less, correct?
Yes, sir.
Yes, sir.
But
Yes,
still
sir.
inside pressure is little higher than, very little higher than outside pressure.
Yes, sir.
Now
Yes, sir.
the here also piston will be pushed in the upward direction, but with dead slow speed, correct?
Yes, sir. Very slowly,
Yes,
sir.
sir.
Very
Yes, sir.
very slowly. It
Yes,
seems
sir.
to be, when you look at the piston, it looks almost to remain constant without moving, but still it is moving, correct?
Yes, sir.
Slowly, yes, sir.
But that mobility we cannot notice.
Yes, sir.
So such a dead slow process is called a reversible process. This is also called quasi, this term is important, static process. Quasi static process, nothing but reversible process. I mean, quasi static stands for very slow process. Okay. Whereas previous all cases what we discussed, they're all realistic, they're all possible. You can notice with which speed the piston moves. Therefore, all reversible processes are practically taken impossible, correct?
Yes, sir.
Yes, sir.
What about all practically possible processes? That means what about all the naturally occurring processes?
They are irreversible,
They
sir.
they must be irreversible, correct?
Yes, sir.
Yes,
Yes,
sir.
Irreversible.
sir.
They must be irreversible. Suppose if there is a water in a dam, there is a slope almost at the gates of the dam. Once you lift up the gates, what will happen? Water will flow
What
automatically.
will flow, sir?
Water.
No,
It's
the
a natural phenomenon.
Yes,
You
sir.
need
Yes.
not to push.
Yes,
You
sir.
need not use any engines for it. It's a natural phenomenon. Suppose if you drop a ball from your hand, it will automatically fall down, right?
Yes, sir.
Yes, sir.
Yes,
Yeah,
sir.
it will fall down automatically. Yes. Therefore, it's a natural phenomenon which is irreversible. Do you think to drop a ball from your hand to the Earth's surface? Do you think it takes some 1 million of years?
No, sir.
No,
No,
sir.
sir.
It takes fraction of seconds.
Yes, sir.
It is irreversible. Therefore, all naturally occurring processes are irreversible. Whereas quasi-static process or a reversible process is ideally impossible. Okay,
Yes, sir.
Yes, sir.
this is the main difference. Write down reversible process and irreversible process. Write two columns. Write down the differences between them. So just partition your page. This is a reversible process. This is irreversible process. Now, when you study any reversible process, for example, take up the same example. Let's say inside which there is a gas in a cylinder. This gas has 1.0000001 atmosphere and outside pressure in the universe some 1 atmosphere. Therefore, piston has to move in the upward direction, correct? But with very slow speed. Therefore, here the driving force which drives the piston in the upward direction. Do you think the driving force between surroundings and system is huge? The difference between the forces or the pressures is very less, right?
Yes,
Yes.
sir.
Yes, sir. Very low, sir.
Yeah, therefore you can generalize the driving force in the case of a reversible process is infinitesimally small. Infinitesimally small. That means very small. Whereas when it comes to realistic process or irreversible process or naturally occurring process, the driving force must be large and it must be finite, right?
Yes, sir.
Yes, sir.
Right on the first difference, right under reversible process. Driving force is infinitesimally small. Driving force is infinitesimally small. Driving force is infinitesimally small.
10 minutes to
There,
5.
therefore, this process takes infinite time for completion. Therefore, this process takes infinite time for completion. Comma, it is imaginary process. It is an imaginary process and cannot be realized in actual practice. Cannot be realized in actual process. Therefore, it is an ideal process. It is an ideal process. It is an ideal process. Okay. Now, write under irreversible process. Did you write that point? Driving force is large and finite?
No, sir.
Yes, sir.
No? Okay, write down. I'll tell once again. The driving force in this process is large and finite. Next, it takes finite time for completion of a process. It takes finite time for the completion of process. All naturally occurring processes are irreversible. Which occur in a particular direction. Under given set of conditions. And
Which occur in a
particular direction under given set of conditions, and it is a real process. Okay, guys. Suppose if you want to study temperature change for a system, you need to study either in terms of dt or delta t. Now dt is preferred to use under which process? Is that under reversible process or irreversible process?
Reversible.
Reversible. Very good. Because the difference must be insignificant. Very small, right?
Yes, sir.
Yes, sir.
Yes, sir.
Whereas delta t is usually preferred for irreversible
Irreversible
process.
process.
Irreversible process.
Irreversible. Of course. This is what to say. Correctly speaking, we have to follow the processes. For a reversible process, you should always use dt. Suppose if you want to measure change in pressure, you should use dp for a reversible process. If you want to measure volume, you should use dv.
TV.
If you want to find out work done, you should use dw. Whereas for an irreversible process, for pressure change, you should use delta P. For volume change,
Delta V.
delta V.
Delta V.
For work done,
W.
delta W. For heat change, delta Q,
Delta Q.
right? And for a reversible process,
DQ.
dQ, right? Therefore, they're all speaking about reversible processes. They're all speaking about irreversible processes. Therefore, can I not give a statement? A reversible heat transfer takes place across the temperature difference dt for in a reversible process.
Yes,
I
sir.
repeat once again. Heat transfer takes place across the temperature difference dt for a reversible process.
Yes, sir.
Yes, sir.
Yes, sir.
Write down. Heat transfer takes place across the temperature difference dt. Heat transfer takes place across the temperature difference dt in a reversible process. Or in a quasi-static process. Similarly, can you frame out the statement for irreversible process? Can you write for irreversible? Yes?
Yes, sir.
Replacing dt by delta t, sir.
Yes, just replace dt by delta t. That's it. And moreover, replace reversible by irreversible. Okay? I'll give the statement. Heat transfer takes place across the temperature difference delta T in an irreversible process.
Sir, across the
Across the temperature difference delta T. Alright. What wrong with it? It is again about to close in 10 minutes. Okay. See. Therefore, when you're talking about a reversible process, can you not tell, see, suppose if the expansion of the gas, suppose if I'm taking, one second, suppose if I'm taking a closed cylinder in which gas is taken, there is a hydrogen gas right inside, and there is a freely movable piston. Let's say outside pressure 1 atmosphere, and inside pressure let it be some 0.999999 atmosphere. Very less. Therefore, piston will move in the downward direction, but in a quasi-static manner, right? Therefore, you need not to specifically tell that it is an irreversible process. It is definitely reversible, right?
yes, sir.
It is definitely reversible. Okay. Now, during this process, can I not tell the system and the surroundings in the entire universe? The system and surroundings are always in equilibrium with each other. Equilibrium in the sense, the process can be reversed at any instant. Suppose if I increase the pressure of the system somehow by just 0.00000011 atmosphere. Suppose if I increase very small value, then what will happen? The total value will little cross 1 atmosphere,
Yes, sir.
right?
The process will stop, sir.
Yes, no, process will not be stopped. Suppose if it is little more than 1, the total value is little more than 1, some 1.0000001 atmosphere.
Not stop, but it will take slow.
It will move up
Yeah,
slowly.
yes, it will start moving in a reverse direction, but of course that also takes a lot of time.
Yes, sir.
Even for the reverse process itself, it takes time, correct?
Yes, sir.
Yes, sir.
Now, for that, in order to reverse the process, did you consume any huge amount of energy to reverse the process?
No, sir.
No, sir.
No, right? You, after all, increased very less value of pressure. For that, you need not to give lot of gas pumping into it. You need not to do that. It is enough to pump even a minute level quantity of hydrogen gas inside, right?
Yes, sir.
Therefore, can you not generalize? The process can be reversed at any instant by simply giving some external force either to the system or surroundings depending upon the process. Suppose if it has to get expanded, you need to increase energy of the system, right?
Yes, sir.
Suppose if it has to get compressed, you need to little decrease the energy of the system. Here I'm not talking in terms of surroundings because surroundings are huge. You cannot simply carry out changes in surroundings, correct?
Yes, sir.
Yes, sir.
Therefore, carrying out changes in system is comparatively meaningful rather than bringing changes into the surroundings. Therefore, a reversible process is the process in which system and surroundings are always in equilibrium with each other, or the process in which or the process which can be reversed at any instant is called reversible process. Whereas, can you do the same in an irreversible process?
No, sir.
No. Suppose if you're taking the same, this is the freely movable piston. This is the hydrogen gas. Let's say the pressure inside some 5 atmospheres and outside 1 atmosphere. Then you will see the sudden raise or sudden push up of
Yes,
the
sir.
piston in the upward direction. Now, during the pushing up, can you simply reverse the process by increasing the pressure to some 1.001 atmosphere pressure?
No, sir.
No,
No.
sir,
You
we
cannot,
have to
right?
increase
You
very
cannot.
significantly.
Yes, significantly you have to raise. Therefore, simply by a little increment in the opposing force, you cannot reverse the process. Right. Now I'll give the definition right on. Right under reversible process. Throughout the process, the system remain throughout the process, the system remain infinitesimally closer to the state of equilibrium to the state of equilibrium to the state of equilibrium. So indirectly it means system and surroundings are almost very close to equilibrium with each other. They are not exactly in equilibrium, but they are very close to equilibrium state. Okay,
Yes, sir.
right now add one more point to the same statement. Um, Therefore, this process can be reversed at any instant. This process can be reversed at any instant. This process can be reversed at any instant. Next, right under irreversible process. the system is far away from state of equilibrium and it cannot be reversed easily.
Sir, the meet is going to end, so we should rejoin this link.
No problem. That's okay. I'm going to close the class for today. I'll continue tomorrow. Okay. Is that clear?
Yes, sir.
Yes,
Okay.
sir.
Right, guys. I'll continue class tomorrow. Take care.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Right, guys.
Thank you, sir. Bye, sir.
Yeah. Bye.
Thank you, sir. Bye, sir.
Thank you, sir. Bye.